Rosie, you want to hang out at the end, or maybe I end up answering it, in which case that's fine too, right?
Yes.
Okay, so
I'll ask at the end.
Okay, let's get started then. Well, good morning, everyone. We are going to be looking at our next section, chapter 3, box and whiskers. There are really a couple of things we're going to do before we get into how do you create this picture called the box and whisker plot. We're going to find out a little bit about percentiles and how to calculate a 5-figure summary, and then how to use that thing called the 5-figure summary to create these box plots. So let's look at the first thing. You might, there's a good chance that a lot of you have came across the term percentile. If you did an SAT, for instance, one of the things they might tell you is that you're in the 23rd percentile, or you're in the 80th percentile, or the 99th percentile, whatever it might be. And for example, imagine that this represented all the different scores that people got, right, in a test or whatever. If you were the 85th percentile, you would be somewhere around about here. What that means that your score, right, whatever your data score was, it was better than 85% of the population, right? So you would have a really good score. So let's suppose that that was getting 90 in the test. So getting 90 in a test could make you the 85th percentile. Some universities, for instance, might use your percentile position in the SAT score. And they might say, you're not going to get into UCLA, right? Or the Massachusetts Institute of Technology, right? Some of the high prestige universities, unless your SAT is in the 80 plus percentile, right? Now, if you think of what an 85th percentile is doing, it's saying like your score, whatever it was, is better than 85% of the rest of the population. Of course, you could look at it in the other way, couldn't you? Also say that the 85th percentile is just another way of saying you're in the top 15%. Would you agree? It's just a different way of looking at the same piece of information. So we tend to talk about percentiles as a way of measuring where a particular data score is in comparison to the population. For instance, if I was a 50th percentile, wouldn't I probably be about where that pen is, right in the middle? I'm better than 50, but 50% of the people are better than me, right? I'm bang in the middle. If I was in the 5th percentile, couldn't I be way over here? Right? I'm only better than 5%. Almost everybody's better than me, you know, if it was my height or weight or score. So that's what a percentile is. Now, we have things called quartiles. So you remember the median and the guy called Q1 and Q3 that we kind of talked about a little bit? Right. And these are called quartiles. Now, if you imagine this is all the data, right, that you've collected, you break the data into 4 equal parts. That's why they're called quartiles. For instance, Q1 is whatever the score that you would need for that to be 25% of all the data. The median is exactly in the middle. Isn't the median 50% better, 50% worse? Right. And then over here, Q3, at that point there, won't there be 3/4 you're better than and 1/4 is better than you? It makes sense then, if you break things into 4 pieces, wouldn't it make sense to call them quartiles, even although there's only 3 quartiles, right? Q1, the median, and Q3. So Q1, right, that guy there, he would be the 25th percentile. Would you agree? Whatever that number is, 25%, 75% better. If you were doing the median, it is the 50th percentile, and Q3 is sometimes described as the 75th percentile. Not very common, but do you know that the median is occasionally called Q2? Does that make sense that you could call it Q2 if you wanted to? But we typically call it a median. And that is pretty much it. That's all you need to know right now about a percentile. So let's look at calculating a 5-figure summary. And we're going to do it by hand. Then I'm going to show you how you can do it using a TI-84. And lastly, we're going to do it by using SOLVE. So what is a 5-figure summary? If you get a list of data, and I'm picking data from question 4 homework. So it's a 4, a 7, a 7, an 8, a 9, a 10, an 11, and a 12, right? That's what the data looks like. And a 5-figure summary consists of 5 numbers. The first number is the lowest value. The next one is Q1. The middle one is the median, also called Q2, but we'll call it the median. Q3, third quartile, and lastly, and what are they calling it? The high value, biased. Right. So, in this data set, these 5 numbers are called the 5-figure summary. 2 of them are pretty easy to do. Would you agree? 4 and 12. They're pretty easy to find, right? The biggest and the smallest. Now, we're doing these by hand. Now, I want to find the median next. And if you look carefully, there's 1, 2, 3, 4, 5, 6, 7, 8 numbers. Now, that means the middle number should be the 4th one, right? There's 8 numbers. The middle one, the median, is the 4th number. 1, 2, 3, 4. 1, 2, 3, 4. Do you see we have a problem? But we've cured that problem before. Can you remember what single number is the median when there's a choice between 2? What do we pick?
The average of the 2.
Right, and that we would call adding them together and half it, right? 8 point. Now, so far so good. Now, since we're doing this by hand, we need to know how do you find Q1 and Q3. So here's the thing. In this, I don't know if you can hear that. Evidently, my phone's been a pain in the butt again. Right. Right in the middle, do you see that little dotted line? Doesn't that split the data exactly into 2 halves? Right. Now, ignore all of those guys. Do you see that what we're left with is a set of 4, the smaller 4 numbers? Q1 is the middle of those guys. Now, if there's only 4 numbers, and my color scheme's getting really messy here, isn't halfway between 7 and 7 the guy? So this guy is 7. Now, on the other side, don't we have 4 big numbers, right? And Q3 is the middle of these 4 numbers. Now, if you're doing the middle of these 4 numbers, would you agree it's what? Halfway between 10 and 11? So we'll call that 10.5. And that is how you get a 5-figure summary by hand. Put the data in order. Smallest, biggest. Find the median. Put that in. Split your data into 2 equal halves. This half, that half. The middle of the small numbers, in this case 7, is Q1. The middle of those 4 numbers, which is what, 10.5, is Q3, and you're good. We comfortable with this doing it by hand? So let's do it by calculator, TI-84. Yes, Aidan, what's your question?
What happens if you have an odd number of data?
Oh,
do you include the median or do you exclude the median?
That is a very good question. Let's do that then. Let's show you a second question by hand, and then I'll go and I'll do them on the TI-84. So 2 sounds better anyway. So I'm just making up some data where there's not an even amount of numbers, but maybe say 11 numbers, right? Let's try that. So 1, 3, 4, 6, 11, 13, 17, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, so this is how do you find the 5-figure summary when there's an odd number of numbers, right? Like 11, right? So I'll write down who all the guys are going to be, and then we'll calculate. We're going to get the lowest. We're going to find Q1. We're going to find what the median is. We're going to find Q3, called the third quartile, and we're going to find the highest. Well, the lowest number is 1. The highest number is 31. There are 11 numbers here. So the middle number is going to be number 6. So 1, 2, 3, 4, 5, 6. That guy. And 1, 2, 3, 4, 5, 6. Do you see there's only one number in the middle? So the median is actually going to be a little bit easier. Right. For instance, see if there's 7 numbers, right? If the data has 7 numbers in it, wouldn't the middle number be the 4th number? Basically add 1 and half it, right? So if there's 21 numbers, 21 add 1 is 22, half of 22 is 11. I bet you the 11th number would be the middle number. Now, 13 is right in the middle. Do you see I've now split my data into 2 groups of 5? Right? The number 13, he basically gets killed, right? Is no longer part of the party. Now, Q1, won't it be the middle of these guys? And would you agree I'm pointing at it? It's 4. And won't Q3 be the middle of the big guys? And I'm pointing at it. It is 22. Does that seem a reasonable approach to that setting circumstance, right? So when there's an even number, won't Q1 be halfway between them? And so you will split your data into 2 even groups like that. And when it's an odd number, it's still the middle number, but won't you, it gets killed, right? Essentially. So we want to do that same question, but we're going to do it now on the TI-84. Now, when it's small data sets, it's actually pretty easy to do, isn't it? You know, I don't think that's too onerous a job. But, you know, as the data gets bigger, it would be easier to use our calculator. So I'm going to use my TI-84 emulator because I like that guy. So I'm going to have to make sure he's up and running. There he is. And now I can switch to him. No, let's try it again. There we go. Can you see the TI-84 emulator now? So on the screen? Okay, thumbs up, good. And I'll put the key press over here. Maybe make it a little bit bigger so I don't run out of space. There you go. So let's do the first one, question 4 then. Start, edit, and then just type in the numbers. In this case, 4, 7, 7, 8, 9, 10, 11, and 12. So we've been here before, right? We've done that before. Put your data in. Then you hit the start button. You move over to calc and choose one variable statistics. And if it's a nice modern one like the emulator, don't you just hit enter, enter, and enter. And if it's this guy, where are we? This fella here, don't you have to do blue button number 1 and enter, right? That's the only minor difference. Right, everything you need to know is in front of us. It's here. I just need to find where it is. And if I hit this button and scroll a little bit, there we go. The 5-figure summary is here. And there is, the minimum was 4, check. Q1 was 7. The median was 8.5. Q3 was 10.5, and the maximum was 12. Didn't that exactly match what we did by hand? You see, it's all there. Now, you can do questions like this in your homework by hand, or you can use the TI-84. I don't think there's really much difference. Whatever one you think's least amount of work, don't matter to me. Are we good with that? Do you need to see another data set on the TI-84, or you think, yeah, I've seen one, I've seen them all? Because isn't the only difference going to be the numbers I type in, right? Everything else is going to pretty much follow it. So far, so good? Right, so good. So we are now going to take these 5 figure summaries, and they are going to be used to create a special diagram called a box and whiskers plot. I actually like this name, box and whiskers plot, because in a lot of textbooks and videos, if you look online, they're just called box plots. I think box and whiskers is a nicer name. So let's take this data set, right, and create box and whiskers. And there are 2 orientations for it. I'm going to do the horizontal one. I think, I don't know, my brain horizontal just looks nicer. Now, this particular data set starts at 4 and finishes at 12. So I'm going to go here and I'm going to start at 0 just because I think it looks nicer. And I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And now I'll fill in all the other numbers. So you draw essentially a ruler, and that ruler has, equal spaces, right? Each one in this case is worth 1. Then you go and you find the smallest number, which is 4, and you make a tiny little mark that looks like that. And then you go to Q1, which is 7, which is here, and you make a mark that's twice as long, right? 2 boxes wide. And then you do the median, which is 8.5, which I would say is here. And then you do Q3, which is 10.5, which I would say is here. So you notice that Q1, the median, and Q3 are much bigger lines. And then you finish with 12, and you do 12 as a little guy. And then you join these together to make the box. And you join these guys together to make the whiskers. Isn't box and whiskers a good name? Because it kind of looks like the thing you're staring at. And if the data had some context to it, you would put a label up here and you might say things like scores in a quiz, or number of children in family, or how many coins were in your pocket, or whatever the data is, right? If it had a context. If it doesn't have a context, you would just do the picture, right? That's all you would do. Now, this is the horizontal orientation, and that's, for me, that's the one I prefer. I like it that way. But you do get orientations where the box plot is done vertically. So just for completeness, I'm going to use this data set, but I'll do a box plot vertically, right? The orientation. So it goes from 1 to 31. So I'm going to have to be a bit more careful about my scale because I don't have 31, right? I just don't have 31 spaces. So it's okay to do a scale. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. And I'll need a 32, won't I? Right? just because the number starts at 1, doesn't it kind of help to see a 0? I mean, it's cosmetic, but it does help, right? Could I have done my box plot starting at 4 and finishing at 12? Yes, there would be nothing wrong with that, but I think 0 looks better. Brandon, what's your question?
So is a candle and wick chart, like for stocks, just a modified box and whisker?
They are very, very similar. I think the box part becomes very skinny in those, don't they? They're just narrower.
They usually don't have a whisker on each side either. It's usually just either up or down.
Oh, then I'm not so sure about that. I thought if it just goes up and down, then they just have a line from here to here and they miss out the box as being anything important. That might be what you're looking at. It's certainly in the family. If it's not the exact same thing, it's certainly in the same basic family, right? So they might be only using that piece of the picture, which only tells you what half the data is doing, or they might be using the whole line, which I think is more likely, because wouldn't that tell you the cheapest and the most expensive, value of the stock that people are buying and selling it?
Yeah, it'll either be the whole box or it'll be the box and then one of the lines, because the bottom of the line will end at where the base of the box is.
Oh, that can happen. If you have a lot of data where all these numbers are the same number, right? Can you imagine this was 13, 13, 13, 13, 13, and then 13? Won't the Q1 and the minimum and the Q3 all end up could be the same number? And what that does is it's one of your whiskers disappears. That could easily happen. Yeah. Now, starting at 1, so I guess I better put my scale in or I'll put it in the wrong place. I'll do a little line, but yeah, that's where 1 is. Put a little red one if you're not sure. Then 4, that's definitely easy thing. 13, it's going to be a little bit messier. 13 would be about here. There's another reason why I like horizontal. It's easy to draw. Q3 is 22. So that one I can do relatively easy. And then finish with 31. It's about here. And then you go like that. And you go like that. And then you go like this. And you go like this. Candlesticks. Is that the term you were using?
Yes, it's a candle and wick.
Candle and wick. I strongly suspect it's just these guys. Just that the data distorts the picture a little bit. Right. Now, if you take a box and whiskers, is what we're going to call it, that's done vertically, if you turn it, doesn't it look just like my guy horizontally? So as long as you start at 0 on the top and finish with the biggest number on the bottom, won't the two be totally equivalent, right? They're not doing different things, they're just orientated differently. I like this direction. It really doesn't matter. Although I'm looking at the homework, and so it does matter. What the homework question does is they give you the data and they ask you to find the 5-figure summary, and then they ask you to draw the picture, and then what they do is the classic, don't they show you 4 of them, but one of them's this guy and the other 3 aren't, right? So that's how you get your homework question done with them. So are we comfortable about how you can create these box and whiskers from 5-figure summaries? Does it seem pretty straightforward how you would approach it? Any questions? Right. Now, side issue. Let's suppose that we've created some box and whiskers. It would be nice if it was possible to answer a little bit about the most likely shape of the data. So it could be skewed to the right, skewed to the left, symmetric, and I'm putting in a 4th choice, no shape. All I mean by that is that it's not one of these 3 things. Now, each one of these, including it has no shape, you can make a reasonable prediction by using these box plots, right? This box and whiskers. So let me show you what they look like. And I'm just going to put the basic pictures down in no particular order. Here are 4 different box plots, right? And let's put a label on them. This is A. The second one I'm going to call B. Third one I'm going to call C. And the last one I'm going to call D. Which one of those 4 is skewed to the right?
B.
Leanna, you say B. So
C.
I heard. And some of you are saying C. Good choice. Right. It's either B or C. Skewed to the right. Now, when you were skewed to the right, doesn't that mean that the data has a big long tail to the right? Right? You want to change your answer, Leanna? Okay. So what you should look at in these pictures is this skinny line is essentially what the tail is. And then this box here kind of emphasizes what the tail has got. Would you agree that the tail is much longer on the right than here? And would you agree that the box is not evenly split? Isn't there more of the box on the right than there is on the left? That combination of big and big on the right, that is skewed to the right. Now, one of those 3 that are left is symmetric or bell-shaped or mound-shaped or whatever name they decide to call it. There are lots of names for the same guy. Which one of those 3 that are left?
Hey.
I think everybody's pretty comfortable with that one. Would you agree that everything is split evenly, right? The 2 tails are pretty much the same length, the guy in the middle. There's a little bit of wiggle room allowed, right? You don't need to get out and say, oh, that's 18 millimeters and that's only 17.5 millimeters. It can't be symmetric anymore, right? Don't be that nitpicky, right? Just if it's pretty much basically balanced as this is, call it symmetric, right? And I think that's fair. Which one of the 2 that's left is skewed left?
B.
B.
Doesn't that have a very similar kind of shape to skewed right, but pointing the other way, right? Isn't the tail big on the left? Isn't the box more of it on the left? Now, a lot of box plots are just mess, right? There is no discernible shape. Now, if you look at this one, would you agree the tail on the left is bigger than the tail on the right? But isn't the box on the right bigger than the box on the left? So what you are looking at here is a situation where there is no particular shape to the data, right? It's not skewed left, neither is it skewed right, or even symmetric. Would you agree is just, what's the word? It's got no name, right? It's got a shape, everything has a shape, but the shape has no name to it, right? Couldn't that be caused by bimodal data? You know, the data just is all over the place. That could be it. Are we good so far? Now, let me return back to our 5-figure summary and tell you that they sometimes ask for something else. They ask for a guy called the interquartile range. Can you remember the calculation using numbers from here for the interquartile range? What was it? Interquartile range. Last chance. Okay, here goes. Okay, Q3 take away Q1. So in this question, the interquartile range would be 10.5 take away 7. The interquartile range is 3.5. In this one, the interquartile range is Q3 take away Q1, which is a score of 22, take away a score of 4, and that is 18. So in this question, the interquartile range would be 18, and here it would be 3. Now, if you're wondering what this number, does it have any connection to the box plots? It actually does. The interquartile range is actually that distance there. Does it make sense why that would be the case? Q3 take away Q1. So the interquartile range, isn't that just a number that tells you how big the box in the middle is? In this question here, wouldn't the interquartile range be the distance from here to here? So if the interquartile range is small, won't the box be tiny? Because most of the data is close to each other, right? And when the interquartile range is big, won't the box be big? Because there's a lot of spread, right? And the interquartile range is one of the numbers that we use, one of the statistics that we use to tell us how spread out our data is. Any questions? Good. Right, let's show you some of those things and what they look like in the homework. Right. So you should be looking at question 5 right now. Agreed? Right. Now, this data set here is only got 20 numbers in it. But I think once you get into anything by 10, won't you use the TIA for? Now, you're being asked to make a box and whiskers, and it ends up being one of these 4 guys. So you're going to get the 5-figure summary from the calculator. You're going to draw it by hand on a piece of paper. You're probably going to do the vertical orientation. And then you're going to look at each one of these pictures, and won't one of them look like yours if you did it right? And whatever one looks like yours, let's pretend it was that one. There's your answer. And then it asks you to find the interquartile range. Well, if you found the 5-figure summary, can't you just do Q3 take away Q1, and that's the interquartile range? Now, if I work backwards, here is a set of data. In fact, that's the set of data that I used as my first set of data. So I can actually put in the numbers here. That was 4. I believe I got this one as 7. This one was 8.5. This one was 10.5. And lastly, this one here was 12. And if you look at our choices here, the median is 8.5. Actually, it isn't the only one where the median is in the right place, that one. So I bet you that's the same picture as I've got. The only difference that they've done, do you notice that they've started at 4 and finished at 12? I guess they're saving space, right? I sometimes make my ruler a little bit bigger just because it looks nicer. In my eyes, anyway, it looks nicer. Oh, and the interquartile range for that one was 3.5. And unfortunately, I don't have the one where I could hit, you know, where you hit the button and it would tell me I'm right. But I know I'm right, so can we pretend I did? Okay. So we would like to use salt, wouldn't we? Because that's the third way to do it. And whenever you see a nice button, you know it's salt. And ooh, none of my box plots have appeared. That's a weird idiosyncrasy. Well, maybe you're seeing it, but I'm not. Do you see any box plots here next to those little dots? No, neither do I. I hope that's just a little hiccup. And, you know, when you go in, it'll be different. Let me try that again. I'll go out. I'll go back in. Oh, let's go in as a student. That might help. Okay. So do that. Open the student view. And there's Box and Whiskers. Okay, and no, it's still missing. I'll try and fix that by maybe changing the question, like deleting it and putting it back in. Maybe that's what it is. We can still do, at least we can do the first part, can't we? And if all else fails, can't you just do 1 not wrong, 2 no wrong, 3 no wrong, 4, and, you know, just do your 5 guesses to get the picture right? I mean, if that's what we need to do. So you hit salt and your data appears, which is good. And I would like to do charts and graphs and box plots. Oh, select a variable, months. And there's my box plot. Can you see the minimum? That number there is Q1. That's the median Q2. That's Q3, and there's finally the last guy. So basically that's what the picture looks like. Now, same data, I'm going to go to descriptive statistics now. And if you go over here, do you see these 5 numbers at the end? Aren't they the 5-figure summary? Right, can you see minimum, Q1, median, Q3, maximum, right? I think with those numbers, you probably should maybe draw your own box plot, and it might make it a little bit easier to see from the choices that you would get. But it's there. Are we good? 5-figure summary, you're good to go. I don't know why that did what it did, but it kind of screwed things up. Okay, here is a survey that was done at Central Hospital to determine how long in months clerical staff had been in their current position. And the responses in months of 20 of them are given in this table. And we're basically going to create a box plot, find interquartile range, and then we'll do a comparison. Okay. So since there is no salt button here, wouldn't you probably do that on your TI-84 calculator? Yeah, I mean, you could do it by hand, but if you want to do that by hand, wouldn't you have to rewrite the numbers in order? Wouldn't that take a lot longer by hand? So since there's no salt button, I would do it by hand, and I get a box plot. And that gives me a chance to do something here. Get something in chat. Okay, everybody's is empty. I'm going to have to just look into why the box plot disappeared. Little weird thing. Right. I want you to imagine that I collected some data, and I collected it, and actually I collected 2 sets of data. And so I'm going to use the same scale, the same ruler on the bottom. And this is 50, 60, 70, 80, let's say 90. And my 2 groups are males and females, self-identified. And we asked them, what's the fastest you've ever done? Right, the fastest in a car or a motorbike, right, that you've ever went. And one of them looked like this. And the other looked like this. And that's what the data for the males who took part in the survey. And this is the data for the females. And so we can use box plots to do compare and contrast questions, right? So if this data was true, males or females, who tends to drive faster?
Males.
Males. Now, does that mean every guy always travels faster than every girl? No. I mean, see the guy that had that number, right? Because each one of these is basically one person, right? This person here, 65 mile an hour is the fastest he's ever gone, but maybe he's got a moped, right? And that's as fast as it can go, right? Who knows what the race is? Maybe he's just really safe and careful. But that guy there that did 65, isn't this woman over here who's done 75? Right? So there are women who go faster than men. So we're not talking specifics, aren't we talking generalizations? So in generalization terms, aren't males likely to go faster than females as a normal, what's the fastest you've driven today, right? It could be how you got here, right? Couldn't you be coming by motorway and coming by, you know, short roads inside towns? Right, next, looking at this data, which one has more variation?
Males as well.
And you typically tell that by looking at the central box. Can you see that that's a big box and that's a much smaller box? So males tend to go faster, but isn't there a lot more variation in the speed that males go, right? If I said to you, what would be the typical middle of the road kind of speed? If it was a female, wouldn't you go down there and I guess you could guess that's about, what, 68? And then if it was a male, you would guess probably about here, what, about 72. Couldn't you say that the typical female goes about 68 miles an hour? That was the fastest that she was going on her way to college. And the typical male was 72. Well, we could talk a little bit about shape. This is the females and all the different speeds that they went. Symmetric, skewed left, skewed right, nothing at all. What would you say?
Symmetric?
Yeah, would you get it roughly the same size? You know, there's a little wiggle, you know, you're always going to give a little wiggle room, right? Because this is like real data isn't perfect, right? Real data, there's a little wiggle room always allowed. Okay, bearing in mind a little bit of wiggle room is allowed, what would you describe the males as?
It looks slightly skewed right.
Yeah, you can stick the word slightly to make you feel, you know, to cover your bases. Yeah. How would I say that? Well, would you agree that this tail is a little bit bigger than that? Maybe not a lot, but a little. And would you agree that that box is probably quite obviously bigger, right? So if the big box and big tail, little box and little tail, isn't that a classic skewed right shape? That's what they look like. And so, do you see the kind of information I could get just by looking at the box plots? Now, here's another one. Someone mentioned stock exchange. So let's have the price during one day of trading that a particular set of two stocks took place at. And let's say that's $100, that's 110, 120, maybe 90 here, 130 there. Okay, I've got a good skill. And no particular reason I'm doing it red, but here it goes. That's stock A. So during one day, the stock sold between 100 and 120, but wouldn't the majority of the stocks would be in that range? And stock B, its box plot for the prices that it sold at right during one business day looked like that. So let's see what we can talk about in this stock compare and contrast. Which stock was the more volatile? In other words, it changed prices a lot, up or down. We don't really know from the picture. Which one varied the most?
B.
B. Would you agree? Bigger box all over the place, right? So A would be a kind of stock that would be bouncing about, whatever these values are. B would be a very volatile stock. Now, we can't tell by looking at that because there's no indication of when the stock was. But can you imagine that the stock started off at 90? Wouldn't this be an example of a stock that was increasing quite rapidly during the day? A lot of volatility, but it was going up. Right? Of course, if it started at 140, wouldn't this same picture be generated? It would just be a stock that was falling badly. So if you were looking at a box plot just on its own, all you can tell really is its volatility, right? Is it changing price a lot or is it not? So it wouldn't necessarily tell you more than that. Which one of these two is symmetric?
A.
What would you describe the shape of B?
Skewed left.
I would do it as a skewed left. So if you get a box plot, do you feel comfortable you could name it skewed left, skewed right, symmetric, or it has no particular shape? Would you feel comfortable about talking about how much variation each is by adjusting, the size of the box? Big boxes, lots of variation, small boxes, not, and that you can compare the prices. This one here looks like it's more expensive than that one. Are we comfortable with those kind of ways to use that information? So I think I shall now return to the homework question and see if I can make more sense of this one. I don't know why it draws that box so low down. Wouldn't it be nicer if the box was a little bit higher? It's just cosmetic, right? But to me, it looks weird. Right, here is your data. You plug it into your TI-84. Won't one of these pictures be the right one? And you'll figure it out by looking. And let's pretend it's that one. And you can get into quartile range. Now, below is a box in Whiskers from 20 nurses at Centre Hospital. So the one that you were doing, right? Compare the plot in A. So you're going to talk about the medians, the location, and the middle values, and the distances and all that. So you're going to say, you know, like I did, women tend to go slower than men. You're going to say the data from here, right, compared to that box plot. So if I could put them together, can we pretend that this was the right answer and this was the other place? Now, if you look at this one and you compare it to that one, would you be able to do some comparisons, right? Okay. Would you agree that data looks like it's got more in the middle, quite close together, but doesn't have a distinct lots of variation at the extremes, right? The tails are much bigger. The median to this one's about 22. The median to that one's about 22. So they're about the same in the medians, but the Q1 and the Q3, well, especially the Q1, isn't the Q1 quite different? This one is at 10. This one's more likely 15. Ah, good. A picture with pictures, right? So this one works. So a lot of data. I'm going to use salt. I'm going to hit, well, let's do the two things. I would hit descriptive statistics, and there's the 5-figure summary that I would use to draw the picture right there. And then I'll go to graphs and charts. I'll do a box plot, tell it to use that, and that's what the vertical one looks like. And okay, where are you hiding? Oh, there we go. There you go. So one of those pictures in front of us is the same thing as the one that I got. So you might want to look at things, where is the median, where is Q1 and Q3, to kind of help you distinguish. You could probably tell with the shape. So I'm going to go back to that in a second. So the shape that I'm looking at here, looking heck, where'd you go? There you are. The shape that I'm looking at, oh, you have to turn your head this way. So the two tails are about the same size, and the box is small on the left and big on the right. So you're going to have to rotate it that way, which is a bit awkward, but I'll live with it. The tails are the same size, and where are you? Box small and then big. So I am going to say it's that picture there. Will you agree? Tails are the same size and the box is a little bit, you turn your head sideways, it's good. I don't know why they go 0 to 20, because isn't it better to go the other way around, because then you could just turn your paper instead of turning your head. And Wyoming has a dropout rate of 7%. Okay, well, if you find 7% here, wherever 7% is, in what quartile does it fall, right? So 7% is about here, right? So it's in this tail. So that tail makes it between, well, it makes it in that quartile, right? It's in the first quartile. It's in the first tail. Oh, good. Here is some compare and contrasts. This set of data, Consumer Reports, rated automobile insurance companies and gave annual premiums for top-rated companies in several states. So although you don't have a lot of numbers here, I want you to think of this as the kind of thing, how much you pay for insurance in different states. So you're looking at these 3 states. There's a lot of variation, right? Because, you know, won't a small car have less insurance than a big honking RV, right? So that's part of it. But shouldn't small cars and big RVs, if everything was the same, wouldn't they have the same insurance rates, right? Well, if you look at these 3, which one of these 3 states has the lowest insurance premium? Texas, Pennsylvania, or California?
California.
And I'm going to say that if you use the minimum to do that, I would agree with you. If you use the medians to compare them, wouldn't you do Texas, California, and Pennsylvania? So if you're using the smallest number, I agree that California, that tail looks to me to be a little bit smaller than the other two. But if you're doing medians, then I would say the middle, right, what the typical person would pay in Texas is about here. California is definitely bigger, and Pennsylvania as well. So based on what I believe they are using, it's that one. So let's submit answer and find out if it was what I think it is or what you thought it was. And I am wrong. So they picked California too. No. I picked Texas and it said no. Oh, there's two parts to it. And who would be the highest? It would be, lowest would be California. And highest would be Pennsylvania. There's only 4 shots at this, so I can't get it wrong. There we go. Okay. Which state has the highest medium? Ah, okay, that's a good word. If you look at these, isn't it Pennsylvania? Now, I'm not answering any more of their questions. I want to answer my questions. I'm looking at this data and I'm thinking, what does that tell me? Because I think it's telling me something quite interesting. If you were going to be in a state, would you agree that in general, isn't Pennsylvania much more expensive to insure your car than Texas? Would you agree? Just looking. Now, are there exceptions? Of course, right? There's some cheap insurances in Pennsylvania and there's some really expensive ones, but isn't that probably a reflection of the car that you're insuring, right? But in general, Pennsylvania is much more expensive than Texas. Has anybody got a clue why Pennsylvania is so high in insurance?
More accidents?
I guess. Is Pennsylvania a big state or a little state? I know it sounds stupid, but I don't know all of American states that well.
Small state compared to California and Texas, anyway.
Right. Is it a small state found with little skinny roads and windy roads and a lot of cars trying to use them? Because that would cause more accidents, wouldn't it? That's what I'm thinking.
No, but it is the East Coast, and their winters out there are brutal. They get a lot of
weather accidents then.
Yeah, probably. And their freeways get really locked up too.
Right. Okay, that makes sense, right? So they're very often reasons, right? The more accidents, don't the insurance have to make higher premiums to pay for the accidents, right? Because they have to pay out money, so they have bigger insurance. If you were going to live in a state, would you go Texas or California? Which one do you think would be cheaper as far as your car goes? Insurance.
Texas for the average person.
Yeah. Would you agree Texas has got quite a small box and most of it is kind of to the left, which means cheaper? Yeah. So Texas, California, then Pennsylvania. That's in general how I would look at this as good to bad. And now I need to go back out and into notes. Get someone got some. Oh, the Autobahn, yeah. Someone mentioned the Autobahn in the notes. Yeah, I believe in the Autobahn there is no speed limit. Which is a bad idea if you're going to have an accident. Going at 120 miles an hour is probably not a good idea. We looked at yesterday how to tell if a piece of data is an outlier. So let me remind you how that goes. I want us to, I guess I should be consistent. I want us to imagine that we already collected some data. In fact, let's use data that's here. So I have the lowest, which is 4. I have Q1, which is 7. I have the median that was 8.5. I have Q3, which is 10.5. And I have the highest, which is 12, right? So I've got my 5-figure summary. And I would like to know when something is probably going to be an outlier. So what we have to calculate first is called IQR. And it's Q3 take away Q1, which in this case is 10.5 take away 7, and that is 3.5. And we calculate a thing called a lower limit. In other textbooks, it's called the lower fence. And we calculate a guy called the upper limit. And in some textbooks, it's called the upper fence. And the lower limit is Q1, take away 1.5 interquartile ranges. And the upper limit is Q3, add 1.5 interquartile ranges. Put a little bubble around that. So let's calculate them then. For this data set, the lower limit is Q1, which is 7, take away 1.5 times an interquartile range of 3.5. So that's going to be 7 take away 1.5 times 3.5, and that ends up being that guy. And so the lower limit is 1.75. Put a little bubble around that to remember. Now I'm going to calculate the upper limit using this formula. And the upper limit is Q3, which is 10.5, add 1.5 interquartile ranges. So that's going to be 10.5, add 5.25, and that ends up being 15.75, and that's called the upper limit. And then we do this. If any number is outside these limits, it is considered an outlier. So the smallest score I've got right now is 4. Is 4 outside of this range, this limits, or is 4 inside it?
Inside.
So it's safe. 4 is not an outlier. And 12 is the biggest number I've got. Would you agree it's also inside this limit, so it's not an outlier? Can we pretend that that was 42? Right? Let's suppose the biggest number was 42. Wouldn't 42 be outside these limits? And that would make it an outlier. So essentially, if you're less than 1.75, you're an outlier. And if you're more than 15.75, you're an outlier. If you're lucky enough just to be equal to these two numbers, you're still safe, right? You have to be bigger than them or less than. That makes sense? That we now have a way of deciding, are you an outlier? Rather than you saying, that looks kind of on the big side, maybe it's an outlier, okay, I think it is. that kind of vague thing. Don't we have a rule now that essentially all statisticians agree on this rule, right? You have to be less than this guy, or you have to be more than that guy, okay? Now, why would outliers cause problems when you draw your box and whiskers? Well, I'm going to make up some data with a bad outlier in it and show you how it makes a problem, right? How it hurts the picture. So I'm going to have 1, 2, 3, 7, 9, 11, 12, 52. Just looking at that raw data, would you have a pretty good guess that 52 is bad news? Would you agree it's an outlier? I mean, just looking at it, it's an outlier, right? I deliberately picked it so big, I'm sure it is one. But I'm going to get a 5-figure summary of this data, and then I'm going to use that 5-figure summary to draw a box plot. And we'll see the damage that one outlier does to my picture. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 numbers here. So I can do the lowest. I'm going to do this by hand because I think it's pretty quick. Q1, the median, Q3, and finally the highest. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Anybody want to tell me which number is the median? There are 9 numbers there. Which of those numbers is right in the middle? And it's just a single number. Who's in the middle?
7.
Yeah. 1, 2, 3, 4, 5. That guy. 1, 2, 3, 4, 5. There you go. 7. The lowest number was 1. The biggest number is 52. So far, so good, right? Now, since that is a number, don't we kill it? In other words, it gets destroyed. You comfortable with that? Right, it's gone. Now, what's the middle of these 4? Would you agree it's 1.5? And cover that guy up. What's the middle of these ones? It's 11.5. Are you pretty comfortable about the numbers I've got, even if I did them quickly, right? So I now want to draw the box plot. And I have 1 and I have 52. So I'm going to start at 0. And since I need to get up to 52, I'm going to have to do a scale like 10, 20, 30, 40, 50, right? I'd have to do a scale like that to get 52, right? And we started with 1, which is about here, roughly. And then we do 1.5, which is there. Then we do 7, which is about here. Then we do 11.5, which is about here. And then we do 52, which is about here. Would you agree that my box plot has been crunched? Most of the numbers, haven't they been crunched into this little area here? And then because of the 52, doesn't that tail travel for a long time? Now it's giving a couple of false impressions. Isn't it giving you a false impression that this tail has a lot of data in it? When you look at it, aren't the other 3 numbers just normal numbers and it's just one big number that's made this tail look really big? If I'd done it even more extreme, I could have made the picture look like this. Can you see you can't tell anything because my little box thing down here is almost non-existent because the outlier was so big? You know, suppose I made that 152. Wouldn't this thing be crunched into a tiny little box here and then a huge long line? Got it. Outliers destroy the look of a box plot, right? They make them look weird. They're not helpful. So what do you think you should do if you have an outlier and it's distorting your pictures, so you can't really see what's going on. And after all, it's just one number, right? What do you think we should do with it?
Say remove a note.
Get rid of it. Remove it from the data set.
Usually in medical paperwork, if they have a box and whisker or something like that, they'll note it below it, but won't include it.
That's exactly what we're going to do. We're going to throw it away to draw the picture, and then we're going to put at the bottom, this excludes an outlier value 52. So we're not totally ignoring it. We're removing it from the picture because hopefully the picture that's now going to be created because of that will tell you much more about the rest of the numbers, right? What everything is doing, not just what that one thing is doing. Now, that essentially means that my data has changed a little bit. There's 2, 4, 6, 8. There's now 8 numbers. Do you see I've killed off 52? Which means I'm going to have to recalculate all of these. And if you had salt or you had your calculator, it wouldn't actually take you that long to do this. It's going to take me a little bit longer because I have to write everything down. Now, since there are 8 numbers here, where is the median? Because it's not a single number anymore, is it?
Step 5.
Right. Isn't it in here? Which is exactly what you said was 5. So I'll make this 1 and I'll make this 12, right? Notice my lowest and my highest are 1 and 12 now. Now, because it's a shared one, don't you put a little invisible wall and you've got 4 small guys, right? And on the other side, you've got 4 big guys, right? So that's going to be a bit messy, but we should be able to do that. Now, forget this box. Wouldn't you agree it's 1.5? And on this side, won't it be what, 10? So when I create my box plot, I've got a lot more real estate that I can use. I like starting at 0. 1 to 12. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Maybe put in 1 more for luck. The lowest is 1, so I'll put that there. Then it goes to 1.5, which is here. Then it goes to 5, which is here. Then it goes to 10, which is here. And then it finishes with 12, which is here. And you can put a little notation like outlier at 52. You see that? Now, when you look at this box plot, don't you get a good idea of what the rest of the data, the majority of the data is doing? Isn't the middle number around about 5, thereabouts? I don't know if I would push this one, but would you agree that's a tiny tail and that's definitely a bigger tail? And when I look at the box, would you agree that this is a little bit bigger than that? So I could get away with a slightly skewed to the right. I guess if I was pushing it, I could. I certainly couldn't tell very easily what the heck that was doing, right? Could tell a lot more from this picture. And that's how you get round, am I an outlier? And if I am an outlier, how you can remove it and do a new box plot without it. So you were talking earlier about the medical stuff, weren't you? So are you, is that your thing? You're going to become a nurse?
I'm pre-med, so I'll transfer when you're done.
Okay. So a lot of this stuff makes sense to you. You've seen it before, right? So if you're looking at, is something an outlier? don't we use our upper and lower limit test? Right, so there's no argument. Everyone uses the same test, so that when you report your data and you do it like this and you say this is an outlier, everybody is saying he's not trying to cheat here or she's not trying to cheat here. There's reasons why that number is considered a little bit strange. What you are not allowed to do, you're not allowed to take your data and say, I don't like those last four numbers because they make a point that's different from what I think reality is, right? I want this to be true, and this data is telling me the opposite. You know that's called cheating, right? You can't just say, I don't like these numbers, and I'll pretend they're outliers, right? Now, outliers can happen for a number of reasons. Sometimes they can just happen by sheer bad luck, right? You just get a patient whose body chemistry is so weird, you know, that weird numbers come out of them, right? When you test them, right? You give them medication and, you know, their heart rate quadruples or something strange, right? That's just randomness. And sometimes outliers happen for the simplest reasons. Do you know sometimes people just make mistakes? Right, so you're writing down a whole load of data and you know it's 5.71, but for some reason, don't you sometimes write 57.1? No particular reason, you just make an error. Those tend to stand out like sore thumbs, don't they? That when you put the data and you analyze it, you say, what the heck is that number doing there? So outliers can just be errors. And sometimes they can be other things. Now, I want to show you one more thing before we finish today. And that is to do with the previous homework. So while I'm getting this set up, do you want to put down your last name for attendance? And I'm just trying to find the darn homework right now. Here we go. I think it's here. Okay. Yes, it is. Okay. Got it set up now. Let's look at the previous section's homework. Remember the variation one? Right. Here is a whole load of data, which I definitely don't want to do by hand. In fact, I'm not even sure I want to do it in the TI-84, but I don't need to. I've got a salt bun. And to get the range, won't you just find the biggest and smallest numbers and subtract them, and that's good. But there's two new guys in town. That guy and that guy. Now they're saying use a calculator, but since the salt button's there, I don't see why I shouldn't use the salt button, right? So I'm about to hit the salt button. Here's our data. Let it do its thing. And we'd go to descriptive statistics, and there's the usual numbers that you get, right? All the kind of values you're expecting. But they asked us for a sigma. That's what that sign that looks like a big, well, it's a Greek letter sigma. And they asked you for the sum and the sum of the squares. Now, do you notice that when I hit, I'll take them off a minute. When I hit sum, do you see they appear here now? And when I hit sum of squares, that appears. So this guy called the sum, right? This one here, that's the number you would get if you added up all the data. And where the heck is my question? I want my question back. Here we go. That's the guy they call the sum. You see it's sigma x, add up the x's. X's mean data, right? Sum the data. And the other one that we had was, I'm trying to find, oh, come back, hello, darlings. I've lost it. Why can't I find things? Oh, there we go. It's the sum of the squares of the data, which is this 164 guy. That's what that guy is. Are we comfortable about that guy now? So that's Salt did it. The sum is this guy. The sum of the squares is this guy. Now, this guy you can get, this guy you can get. This guy is missing. So let's just pretend that this guy is 2.5. What's that guy equal to? Or what calculation would you do to get that guy? Look at its name, S squared. That's the clue.
$6.25.
Just find out what 2.5 squared is. 6.25. Does that make sense? Right. Can you remember the coefficient of variation? It's the mean, which I'm just pretending is 34, divided by, I got that the wrong way around, didn't I? It's 2.5 divided by 34, multiplied by 100. So it's standard deviation divided by mean times 100. So I'll do a quick one on that. 2.5 divided by 34 times 100, and to the nearest whole number, that's about, if those numbers above were correct, that would be a 7% coefficient of variation. And some questions about, you know, what you get and what you don't get. Now, we did yesterday, didn't we, do the Chebyshev guy? Remember the 1 minus 1 over k squared, that guy? I think that's everything. Any questions before we go? We should finish with a bad joke. Rosie, yes.
Can we go over number 7?
From that section?
Yes.
Is that your homework question that you were asking me about earlier? Okay.
Mhm.
If any of you are interested here, just hang about and you can see question 7. I'm sure if it caused trouble with one person, it's going to cause trouble with quite a few of you. So, okay. So let me go straight into that and do the question then. I've lost my place. Give me a minute. There we go. Now, the coefficient of variation here is going to be S over 24, right? Let's get that the right way around. Right. S4 over 20, not 24, times a percentage. Well, I happen to know that that's 24 in here. Yeah, that's 20%. Are you comfortable about 20% where I got that? That's not the issue. So it's this Chebyshev guy. This I'm going to have to do some writing with, so you're going to have to bear with me for a minute. Now, Chebyshev went and says that if your k standard deviations away, the percentage of the data you get is that guy, right? You comfortable with that? Right. So what we're going to be looking at next, just getting this thing set up so I can double check when I hit the numbers I'm doing it right. Coming up, just checking it's here. God, it takes forever. Okay. So if you are going to get 75% Chebyshev interval, what I need to do is, don't I need to figure out who k is? How many standard deviations it would take to get 75%. So this actually is an equation. I want to know what value of k is how many standard deviations, gives you 75%. You can solve this all sorts of different ways. Any suggestions? I've got one in my head, but maybe you'll come up with a cleaner way. I want to find k. What could I do here? Okay. I will subtract 1 from both sides. I will get rid of the negatives from both sides. If I turn this guy upside down, I can turn this guy upside down. Or, if you don't like that, I can cross multiply. And that means I can now divide both sides by 0.25. And I get 4. And that makes K 2. So I now know how many standard deviations to use. Now, the data that this came from had a mean of 20 and a standard deviation of 4. So you want an interval that has 2 of these. So that's going to be the mean plus or minus 2 standard deviations. So it's going to be the mean plus or minus 2 times 4. The mean is 20 plus or minus 8. That gives you an interval from 12 to 28. So the lower limit is 12 and the upper limit is 28, which is the right answer because I can see it over here. Now, if you wanted, I don't know, 80% Chebyshev, wouldn't you be starting with solving when is this guy equal to 0.8? And you might find that you need 2.1 standard deviations. Well, if that was the answer, wouldn't you just go X bar plus or minus 2.1 standard deviations? And that would get you the interval. So basically, as long as I know the mean and standard deviation, can't I find any interval I like? I can tell you the interval where 99% of the data is, or only 10%. And I do that by putting 99 there, or 0.1 there.